Welcome back to the wood shop. My name's Brett. Today I'm going to be turning this stack of reclaimed barnwood into 4 matching floating shelves. I say I'm building these today, but who are we kidding? This is going to take a couple of weeks probably. I have a full-time job too. These shelves are for a customer, and they're also going to be stained to match the fireplace mantle that I made for them earlier. You can see a playlist on how I built the mantle in the link up here. I'll also add a link in the description below. So let's get started. Well, now I'm back up in the garage and I'm going to do the same thing that I did with the wood for the mantle. I'm going to go through it with the metal detector and try to find all the nails and any metal that's in this wood, and then go ahead and remove that. Well, I didn't actually find any nails in any of these boards. I was surprised. Now it's time to do some power cleaning with a nylon brush. I was grateful for another beautiful day to do this outside. So here's some of what I'm working with. The shelves are going to be 44 inches long. I think I need a final measurement once I get back to the work site, but my approximate length was 44. This board is 88 and 5/8 inches long. So potentially I could get all 4 front edges of the shelves. I like the thickness of this board. It's almost 2 inches thick. It's just shy of 2 inches, and it's got a nice weathered look, and it's solid on both edges. Pretty much the full length. There's not any major issues. As you can see here, the reason I can't turn this thing into 2 shelves of solid lumber is I've got this ginormous crack running through and it's full thickness. I'm going to take you to a diagram in just a bit. But like I said, I can probably get all 4 front edges of the shelves out of this at the full thickness. But I've got this one as a backup. It's not quite as thick, but it's got some nice wormholes, and this will give me 2 edges at 44 inches. The full board's not quite long enough. This is the longest board that I have. But this one only measures 1 5/8 inches thick. So either I'm going to do 2 shelves at 1 5/8 and 2 shelves at 2 inches thick, or I'm going to try to do all 4 in the 2 inch. I've got this one back here that's also a nice thick board. I think it was 1 3/4. Yeah, this one's 1 3/4 thick. But the problem with this one is it's got a lot of fungal rot on this one edge, and it's also got this bark on this edge, which could work out okay, but it's also got quite a big bow in the board. So I'm probably not going to use this one for an edge. In fact, I'm pretty sure I won't, but I may use it for the faces of the shelf. So here's my plan. This is just the front edge of the shelves. The back edge is going to be up against the wall, so that doesn't need to be pretty. But that one board that I pointed out is 1 5/8 inches thick. The other one is 1 15/16. I'm going to cut 3 inches of it off each edge, and then I'm going to keep 2 inches of it full thickness, and then trim down a rabbet on this one of 5/8 inch depth, and that'll be top and bottom. And I'm going to leave a 3/4 inch core, and I'm going to use MDF as a substrate, and then laminate barnwood on the top and the bottom. I hope that makes sense. Here I'm ripping 3 inches off of both edges of this board to make the front edges of all 4 shelves. I used a 24 tooth ripping blade for this. Links to all the tools I use in this video can be found in the description below. Now, after ripping those 3-inch pieces out of this board, I went ahead and clamped the outer faces together, allowing the cut edge to be facing out on both sides. And I'm going to let that sit overnight in clamps so it has time to dry out, hopefully without warping too much. That's why I'm using the clamps. It's still probably going to warp some, and then I have other cuts to make which will expose more wood. But this wood is really old, so it shouldn't have a ton of movement, but we'll see. I'll be using this board for either the top or the bottom face of one shelf, and here I'm just trimming it down to approximate length on the miter saw before I resaw it on the bandsaw. These setup blocks are from Carter Tools. I'm combining a 1/2 inch and a 1/4 inch to give me approximately a 3/4 inch thick piece. They're magnetic, so they stick tightly to each other and to the blade to help me line up the fence. Next, I'll be cross-cutting those 3-inch wide boards in half lengthwise to give me 4 front faces. So I swapped out the rip blade for a combination blade to make the cross-cuts. And now I'm dividing up this 3/4 inch sheet of MDF with the substrate inside the shelves. The wide offcut always has a tendency to spin a little at the tail end of the cut. So to prevent that, I'm using the miter gauge to push it straight past the blade for a cleaner and safer cut. Switching back to the ripping blade to straighten out the edge of the laminations. I use a melamine shelf with toggle clamps as a jointing sled to make long straight edge cuts on uneven boards. Once I have one straight edge, then I can spin it around and use the fence without the jointing sled. Okay, here's what I've got so far. This is the face of one shelf. These are going to be really beefy shelves. This is just shy of 2 inches thick. And I'll spin this around and show you my plan here. Got one piece that's still a bit too wide. And then I'm going to sandwich some MDF. And then another piece on top. So I was just checking to make sure that everything is still thick enough and is gonna match up, but it looks like this end here is a little thicker. We got some sticking up over here, but this end is matching up pretty good. So I've got to plane this one down till it matches the thickness of this end, and then trim this bottom one down so it's the right shelf depth. So kind of a thick lamination sandwich. Next, I'm cutting rabbets, or rebates as they say in the UK, on the top and the bottom inside edge. For this, I'm using my box joint blades because they have a nice flat grind that doesn't leave any grooves in the rabbet. This 2-blade set will give me either a 1/4 inch or a 3/8 inch cut, so I have to make several passes to get a 1-inch rabbet. Now for a test fit to see if any adjustments need to be made. This contraption is my veneer press. It's made from 2 giant plastic cutting boards. Plastic cutting boards because the glue won't stick to them. They're 18 by 24 inches. And then you just put whatever you're gluing up between the cutting boards. Then I have solid oak cawls, I guess you'd call them. And they're on threaded rods. And just tighten the nuts down and squeeze the heck out of whatever's in your sandwich. Today I'm not going to be using the press part of it. I'm just using the cawls on the threaded rods to apply clamping pressure as I glue up my shelves. I taped off where the shelf rods will go with painter's tape because I'm going to be drilling holes in a later step and I don't want to hit any of the micro pins with my drill bit. In order to achieve a more consistent veneer thickness, I'm using a different method for resawing. My first cuts are with the ripping blade raised to full height, and the board is clamped to a sacrificial fence that rides over the top of my table saw fence. This will allow me to get thinner veneers out of both faces of this board. Then I finished the cut with the Resaw blade on the bandsaw. The box joint blade set was a little too thin, and it was a bit time consuming to make all those passes. So for the rabbets on the rest of the shelves, I busted out my Dado set and used the entire stack, which cut me close to 1 inch. It leaves just enough length on the arbor bolt to fit the washer and the nut to hold the blades on. This dado set does leave a small groove in the inside surface, but that's no big deal because no one will see the ends of these shelves. The grooves are just someplace for the glue to settle into. Making a few test cuts to get the height dialed in. Well, this is the first shelf that I made, and it was close to my original plan of close to 5/8 inches with a full 3/4 inch MDF core. The problem I ran into with doing that is when I resawed these two boards, this took two boards to make two faces, the offcut on the bandsaw ended up being pretty thin. This is one of them. And so obviously I wasn't going to be able to use this face as a 5/8 inch lamination or veneer. So I had to switch tactics. I also ran out of barnwood. I guess I didn't bring home quite enough to do everything that I wanted to do with the thickness that I thought I needed. So I had to switch it to a thinner veneer and then double up on the MDF for the core. So this is what I've been working on now. A much thinner veneer. Like I said, two layers of MDF instead of just the one. And so the dados on the front edge piece are a lot thinner than they were on this first shelf that I made. Another issue I ran into was that this 2-inch thick board wasn't uniformly 2 inches thick the full length. And this one, for example, was 2 3/64 inch thick on this end, and only 1 7/8 inch thick on this side. So not even 2 inches. So when I ran it through the table saw and cut these dados in to receive the veneer laminations, my core where the MDF will be is tapered. So that means I'm going to have to somehow taper the MDF so that it doesn't push the finished face up off of the surface of the shelf. This is barnwood, and it is kind of tricky to work with because obviously we want to keep the character of the face. That's the whole reason of using barnwood or reclaimed wood, right? So that means that you can only dimension the back side, making it thinner or flatter. You can't really take out twist or bow on the face because then that removes the character. This is a different way of doing woodworking, and I'm learning a lot as I do it. I still think it's really cool to have the character of the barnwood, and I would definitely do it again.
Totes my goats!
But there seems to be a lot more workarounds that I'm finding. So as I was laying in bed this morning, actually this afternoon because I work nights, it came to me, I couldn't figure out how I was gonna taper this long section of MDF. I can't do it on the bandsaw really because I don't have enough control to make a gradual taper. But what I can do is pass it over a straight bit on the router table and then incrementally decrease the height of the bit as I make passes sequentially along the MDF core. So that's what I'm going to do. I'm going to taper it on the router table. Well, let's see how we did. This is the board I just tapered on the router table. Yeah, that worked. It's flush here, it's flush there. Before I tapered this, one of the sides was sticking up 3/32 of an inch from this front edge. Yeah, that worked. Almost ready for glue up. I'm gonna trim this down. This is a trick I learned from Matt Outlaw on his channel 731 Woodworks. He used a long level at the table saw fence to joint a board, but it works for making a straight rabbet as well. As you can see, this edge board is a little uneven and bowed, and if I were to run just the board along the fence, that bow would show up in the cut I'm making, and it would create a gap between the lamination and the edge board. Here I'm using a self-centering doweling jig to drill a pilot hole in the back edge of the shelf. This will make sure that my hole is exactly centered as well as straight up and down. This auger bit is, I think, 12 inches long. I'm a tall guy, but this was a little awkward drilling at counter height. So I ended up bringing the shelf down to the floor to drill out the 3/4 inch holes 6 inches deep for the floating shelf rods.
Two hours later.
The process of drilling 12 holes 6 inches deep really put my drills through the paces. My cordless drill just stopped working because it was overheated, and my corded drill started smoking from the motor. Thankfully, I have a third drill, and that finished the job like a champ. This process is pretty straightforward. I just brushed on the stain with a paintbrush. The Lazy Susan is a big help for effortless repositioning. I had made these templates of the shelf brackets out of hardboard to help me get the right positioning on the wall. They also assisted me in drilling pilot holes in the studs using a self-centering drill bit. I followed those up with a larger bit that was slightly skinnier than the 1/4 inch lag screws that I was using for mounting the brackets. Getting these shelves to seat fully took a little persuasion. Thankfully, they're made out of solid oak.